Did Indian Ocean swell actually hit California? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Monday, June 2nd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, I'm sure you will, be sure and write it up down below. I'd be happy to respond. And if you'd like to make a contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Coach Nate, Tim Caston, Iowa, Our Predicament, Peter Carpenter, E. Slate, Evolution Moto, Dave Frankel, an anonymous contributor, I know who you are, and a very generous contribution from Don Mendatron. Thank you so much, everybody. I really appreciate your contributions. They help keep this channel going. And with that, let's get to work. So just to be clear, this is a repeat, exact same content from the video that was posted last night on Sunday, the 1st of June. But there was audio issues with that video, so I'm redoing the whole thing. I think I've got that all resolved now, so much more listenable, hopefully. Still an hour long, still a lot of details. Hopefully you won't fall asleep, but lots of exciting data buried in here. All right, let's get to work. We're going to start by looking at significant wave heights around the planet. Starting up in the North Pacific, not a whole lot going on. Of note here, a gale, literally a gale off of Cape Mendocino. And now it's not a wintertime-like gale. It is really a pressure gradient generating 35 plus knot winds. We'll get into that. This is really kind of a summer, kind of a not unusual summertime weather phenomenon. Good for producing wind swell. Down to the South Pacific, a gale is fading southeast of New Zealand, still with like 27-foot seas aimed off to the northeast. Swell is radiating to the northeast, targeting Hawaii and the U.S. West Coast. North Atlantic, things pretty quiet. South Atlantic, things pretty quiet. Indian Ocean, a gale with 32.8-foot seas. So this number right here is the highest seas over the entire image or domain here, and here are the actual coordinates. Highest winds at that same location, 46 knots. So swell is being generated targeting Indonesia and Western Australia. But before we get into all that, let's take a look at current conditions. We're going to start by looking at the buoys up off of Oregon, actually the Oregon-Washington border. Grays Harbor buoy number 036. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period. That'd be very long period swell, which there is none. The whole way down to 5 second period, just pure wind chop. And they're a little bit there, but mainly you see wind swell in about the 9 second period range and some background energy, presumably southern hemi swell hitting there. Primary swell 7.4 feet at 9.3 seconds from 300 degrees. That would make surf theoretically at 6.9 feet at your average beach break. A break with no swell enhanced bathymetry or likewise no offshore reefs or land mass or something to shadow and or block the swell. Heading south, we go to the Point Reyes buoy off of just north of San Francisco, California. Buoy number 029. A much more pronounced wind swell signature here with energy ranging from 5 seconds up to 13 seconds. And then you see southern hemi swell in the mix as well, but it's pretty much a convoluted mess. Primary swell 8.8 feet at 12.2 seconds from 329 degrees. That would be shadowed relative to San Francisco, so you're not going to have 10.7 foot surf, but you'll have something less because Point Reyes kind of blocks some of that energy. And then more wind swell, 7.9 feet at 9.2 seconds. I mean, the reality is the algorithm is having difficulty teasing out, well, is that a swell? Is that a swell? You know, and then by the time it gets down here, well, it only tracks the first 2 swells, but clearly there's a 3rd swell in the mix. And I guess I could go play with all the math to try to tease 3 out, but probably not worth it at this point. Then we go down to Southern California, the Point Loma South buoy, 191 there off of San Diego. Now, this is probably the best way to see Southern Hemi swell, unadulterated by northwest wind swell. Here you go. There it is, plain as day at 16.7 seconds. Yes, there is still some wind swell down here, but this becomes the primary swell. And the reality is what's hitting down there, really, it's not that far of a distance, especially if it's like a southwest direction between, I'll say, Dana Point and Santa Cruz. A couple hundred miles difference, not even that. Primary swell, 3.3 feet at 16 seconds from 191 degrees. Surf from primary swell, 5.4 feet. Just looked at the cams. So at top facing break, south facing breaks with good bathymetry, you can get 1.5 to 1 3/4 times that amount, and 1 to 2 feet overhead surf seems pretty typical on the sets today for this swell. And then secondary swell, 2 feet at 13 seconds from 210 degrees, theoretically making surf at 2.6 feet. Yes, I guess I see that. Probably not, though. A little bit of an anomaly, I'd say. And then our final stop, we head over to the south shore of the Hawaiian Islands, the Lanai buoy number 239. There is Southern Hemi swell there, pretty small. You see it here on the chart, somewhere in the 13, 14 second period range. Primary swell, 2.1 feet at 10.4 seconds. Oh, that's the wind swell from 193 degrees. Then here's your Southern Hemi swell, 1.3 feet at 15.2 seconds from 187 degrees. Notice the difference. What makes primary? It's the calculated surf height, 2.2 feet versus 2.0 feet. So 6 of one, half dozen of another, I guess. I still don't know. Oh, but I see. The period, the bandwidth on the wind swell is broader. Notice, as you get lower and lower here, 7.1 to 7.7 to 8.3, you're only talking like a half of a second period difference. When you start getting up here, 14.3, 15.4, that's 1 second. 16.7 to 18, then you're into 2 seconds. Notice when you get up here, there's almost 5 seconds of period difference up in the higher bands. It would actually be interesting to see if they could make some buoys that had more sensors that could tease out what's going on subtly here. What I do in calculating these periods, though, is I do a best fit, a weighted average to try and guesstimate exactly where the period is on each of these swells. The point being is over time, as the period decreases, I want to be able to see it, down to almost the 10th of a second. So basically apply some fancy math to try to see if you can tease that out. All right, what's been going on over the past week? If there's swell in the water, it wasn't generated right now. It's probably been generated over, days or a week ago. And that swell takes a while to propagate, especially into California from the Southern Hemi. Anyway, we're going to start by looking at the North Pacific. There was a gale. This gale previously was stronger. It produced swell for the Hawaiian Islands. But then another system developed on Tuesday, the 27th of May, producing 21-foot seas, fell southeast. Swell from that system actually did arrive at the Hawaiian Islands. You see the leading edge right there on Saturday, 1st of May. Made head-high surf, maybe a little bit more. Then that faded out. Another gale, here we are on Sunday, was producing 21-foot seas aimed north, all of Alaska, doing really nothing. But then the gradient started building off of Cape Mendocino on Sunday. We'll go into the best I have is a 6C run of the model here. 21-foot seas as of, this is really like late Sunday night, pushing down the coast. Now, again, that is not a gale. It is a local gradient. I'll show you the charts on all that in a little bit, but that is the primary swell source other than Southern Hemi swell for California at the moment, and the major swell source in the North Pacific. Now, in the South Pacific, starting 06C Saturday, the 24th of May, a gale started developing southeast of New Zealand with, like 25-foot seas, then started building to 28 feet, barely 30 feet on 18Z Saturday, continuing about 29.4 feet. There we go. We got up to 31.7-foot seas late Saturday night, early Sunday, the 25th. There is the ice anomaly popping back up. And then that system continued. Now, it doesn't look like very much on the charts because it only had like maybe 31-foot seas, but mainly 29-foot seas. But it was lifting from south to northeast, and it basically traversed the entire California swell window. Swell from this system, as of today, is hitting all exposed breaks in Southern and North California, though North California pretty buried in local wind swell as well. You can see here on Tuesday, the 27th of May, it was east of even the San Diego swell window. San Diego about, I think it's 117.5 west. So that was the end of that. Swell also has, of course, already radiated into Chile and Peru up into Central America. Then we're into Wednesday, 28th of May, looking for any other meaningful swell source. There is a little bit of 30-foot seas that developed on Thursday, but again, they're pushing mainly due east. It is that track up to the northeast that really pushes energy up into Hawaii and into California. Then we're into Friday, and let's see, Saturday. Now, here is the next gale in the series that started developing. I'm going back in time here. On Saturday, well, actually, we can go back because you can see even there on Wednesday, 28th of May, gale developed. Fiji right there in the Tasman Sea, 26, 27-foot seas. Of course, swell from that has already passed Fiji. Another one south of the Tasman Sea developed with 20, 22, 24, 27-foot seas aimed northeast, up to 30 feet. That swell, pretty, probably just looking at the leading edge here, about hitting Fiji as we speak, but of more interest, it redeveloped here south and southeast of New Zealand with seas up to 34 feet. Yeah, that was about it, 34 feet, and lifting off to the northeast. You see it there. Swell from that system now is radiating off to the northeast too. So we have one swell hitting the California coast, another on the way. This one better positioned and aimed at Hawaii, so Hawaii should maybe get a little bit bigger shot of swell about a week out. So by this coming weekend, swell expected into the Hawaiian Islands, and maybe 2 days after that for California. To the North Atlantic, little gale here. This was over a week ago, pushing into the UK in that area. Local wind swell, probably pretty raw. And then we're looking to see if anything else meaningful, by meaningful I'm saying 20-foot seas or higher, has developed, and not really. It is late in the season and pretty much so meteorologically, we're in summer. Summer starts on June 1st. Astronomically, it starts on June either the 20th or the 21st. And if you're a teacher, summer starts whenever the kids are out of school. To the South Atlantic, a gale developed south of Africa, all energy pretty much aimed off to the east. But there's this others, I don't know, secondary energy, 22-foot seas that developed. Either way, swell from this system. I saw some videos online that suggested swell did hit. It wasn't huge, but there was something rideable. Now we're into Wednesday. Another system, same sort of deal, falling east to almost southeast. And then yet another here. This was on Friday with 30-foot seas pushing south of South Africa into Saturday the 31st. Certainly swell energy. You can see it pushing into all this area right in here. How raw it is a different story, but any surf is better than no surf. And then let's see. Oh, let's get back to, yep. Oh, 12Z running the model picked in here. Okay, we got it. So, and here we are, current time. So the real focus appears to be the Indian Ocean, not so much the South Atlantic. And then again, one last stop, Indian Ocean, going back a week, 25th of May, Sunday. You see gales almost pushing southeast, not doing a whole lot. But you see a swell front here pushing to the northeast. I mean, there's just an agitated sea state here. So for sure, some swell will result from that. Probably not huge. Now, here we are on Saturday, 31st of May, a gale with 32-foot seas, 32-foot seas developed off of Western Australia, targeting Indonesia and Western Australia, and much more energy, though kind of diffuse and not well concentrated, was pushing under Africa. And here we are, current time, gale with 34-foot seas. aimed pretty well to the northeast. So a steady swell pattern for the Indian Ocean. And now to the title of this video. Did swell from the Indian Ocean actually arrive in California? So on 6Z Monday, the 19th of May, so what is that? 2 weeks ago, a storm developed in the Indian Ocean with 54.3 foot seas. Now notice the arrows, it's kind of aimed almost southeast. And last week's video, we did the examination of the Great Circle paths from this location up into California. And in fact, yes, there is a clear and direct path from where this storm was when it pushes actually southeast, or when seas are pushing southeast, right up into Southern California. I think it was like the 217.5 degree track. Let's see if I have it here in my sticky. 217.19 degree track. Okay. And so the plan was in last week's video to see when and if the swell actually hit in Southern California. Now, the storm was 9,700 nautical miles away, almost 10,000 miles away. So would this swell be rideable? I mean, pretty much we all said no, not a chance, or at least I said it. But if we even saw any energy hitting the buoys in Southern California, that would be kind of a really neat science experiment. So I went and figured out the math and said, okay, 25-second energy should be arriving on Wednesday, the 28th of May at about 7 p.m. Period dropping to about 22 seconds on Friday, the 30th at 4 a.m., and then down to 20 seconds on Saturday, the 31st at about 9 a.m. So let's go take a look at one of the buoys in Southern California and see what happened. All right, so swell was supposed to arrive on the 28th at 7 p.m., and the 29th is really the 28th if you do the Zulu conversion. Okay, so this was about 1 a.m. Thursday morning. You can see right here, 25 seconds, 0.2 of a foot. And you go, well, is that really swell? And that was kind of my thought. It could be just noise. There's a steady background, 1/10 of a foot of energy background noise here. So let's go look through a series of slides. On Thursday at 15Z, so what's that, about 8 a.m.? Notice we have 0.3 of a foot, and it's actually a little, maybe almost up at like 26 seconds. And then by 11:30, 0.3 of a foot solid. So there is some swell coming in from somewhere at 25-second period with a 25-second period, 1/3 of a foot. Okay, with the energy on either side, we'll call it maybe 1/2 a foot at 25 seconds. So that would be like wave heights of 1.2 feet, 1.5 feet. But it certainly appears that something was hitting. Again, this is buoy 191 there off of San Diego. And then at 2 p.m. in the afternoon, well, look at this. We got 0.2 of a foot at 25 seconds, 0.3 at 22 seconds, 0.2 at 20 seconds. So if anything, the size is building. And then by Thursday night, up to 0.4 of a foot with energy on either side. So that's solidly 1/2 a foot, maybe even more at 25 seconds. So, you're into 2-foot surf top spots, maybe waist high. Now, was it rideable? Well, some of our readers from the previous video said, yeah, in fact, it was at select locations. They were out on Thursday, and this would be, late Thursday. And definitely it was rideable. It'd probably be one set every half an hour with 1 or 2 waves in it. And then pretty much holding in the evening. And then as we got into Friday morning, 14Z, so that's 7 a.m., 1/2 a foot at 22 seconds, and period was supposed to switch to 22 seconds at 4 a.m. on Friday. So this tracks perfectly, and look at that energy out at 25 down to 20. So maybe 3/4 of a foot at 22 seconds. So, we're talking rideable surf, barely, but rideable. And then later in the morning, 0.6 of a foot at 22 seconds. And again at 2 o'clock in the afternoon. And then Saturday up to 0.8 of a foot. So this would have been 1 foot at 22 seconds. That would have been, with the long period, waist high surf from the Indian Ocean if you were there, if you were on it. So I think it's pretty safe to say some swell from the Indian Ocean did actually reach Southern California, and that surf probably was rideable. Now, if you didn't know what was going on, you wouldn't have had a clue. But if you did know what was going on and you were there and you did actually catch a wave, I would say that was probably a once in a lifetime or maybe once in a 20-year sort of event that you would actually get rideable surf from the Indian Ocean. I've been playing this game for quite a few decades now, trying to look and see, well, I know where the Great Circle Paths are, but does any swell ever actually materialize from the Indian Ocean? At least in this one case, I would say definitively, yes, it has. And if you were one of the people that got to ride that swell, good for you, man. That was certainly a once-in-a-lifetime opportunity. All right, so let's go look towards the future now. We're going to start by looking at jet stream level winds, and we're really focusing on the South Pacific here. We're looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. What that does is helps create a clockwise circulation in the upper atmosphere. That typically manifests itself down at the ocean surface. That is a clockwise circulation in the southern hemi is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, generating seas. Those seas, as they radiate away from the fetch area, the lesser period elements decay off, exposing longer period swell. And of course, swell, when hits your beach, creates surf. But it all starts with the trough in the upper atmosphere. Now, we know there was a gale here southeast of New Zealand. This is the remnant trough that supported that gale, and it likely is to fade out. As we move into Wednesday, a ridge starts building. The jet, you can see it pushing south. You get this split flow. You see the same deal going on over here, a ridge pushing south. That's high pressure in between the split jet there. Does nothing for producing surf, but you almost get the sense a little bit of a trough is to start organizing here over the southeast Pacific. Winds feeding it up to 160 knots into Thursday, but then it kind of fades. But look at this, winds start building to almost 200 knots. Again, in this ridge pushing south with a little bit of lift over here. Now again, San Diego cut off about 117 west. The axis, the northmost axis of this trough is east of the Southern California swell window. So this definitely looks like something that could support swell pushing into South America, but not so much California. Notice the massively split flow behind this as we're into Sunday, almost a week from now, June 8th. And then let's just take this thing on out. Same sort of deal, very split, jet displaced well to the south, and just this strange elongated pattern here. I'd say the South Pacific, at least for a little bit here, is going to take a break. Let's move on. So here we are, surface level pressure, surface level winds. It takes wind blowing on the ocean surface, not 30,000 feet up in the atmosphere. The jet stream is the foundation. This is the actual meat of the matter here. So remnants of the gale southeast of New Zealand still producing 30 to barely 35 knot southwest winds, but that's only good for like 12 to maybe 13 second period swell. That sort of a swell would not survive the long journey up into Northern California or even Southern California. So that system pretty much gone. Then we're pushing on out. Wednesday, here's 40 knot winds, but they're all aimed south. Another little pocket. We know there's a trough trying to get organized here. 40 knot winds pushing almost to 45 knots, but over a small area and not lasting very long and out of the Southern California swell window. And then continuing on into Friday, no real, here comes the gale. Oh, notice all the energy aimed south. This was the hope for, some energy maybe for Chile, but by and large, not your optimal swell production setup, especially when gales are falling south and your targets are all off to the north. There's a little bit of a cutoff low here, but it not doing anything relative to New Zealand. And here we are a week out. Plenty of wind, all aligned either east to west or pushing south, but just no clear 40-knot winds aimed off to the northeast, so probably no real obvious support for gale production. All right, so what effect do those winds have on the ocean surface? We're going to start in the South Pacific. There is our remnant gale, no real energy. Notice the model updated 12Z Monday. That fades out. Let's see if we have anything else. Next gale pushing southeast, nothing on Thursday, the 6th of June. Now we are expecting to see something over here. Here we are into Saturday. What was that? 27-foot seas aimed northeast, but that is pretty much east of even the San Diego swell window. And we're out. There we are, a week out. So really, after the gale south of New Zealand, which is pretty much wrapping up now, nothing really forecast for the next week in the South Pacific. Next up, we go to the North Pacific. There is, let's go back and just look at this. Monday, 12Z, 21.6-foot seas from a local gradient. Pretty good. Now you see the gradient fading out, but still present the whole way into Tuesday and Wednesday. I'm focusing on this because there's literally nothing else unless some tropical activity pops up. Or into Thursday, Friday, the gradient continues, but slowly weakening into Saturday and Sunday. And there we have faint hints of a tropical system, another tropical system off the Philippines. This is is a week out. I believe none of it in the GFS model, especially in regards to tropical system, is pretty much worthless more than about 3 days out. So for the most part, the North Pacific asleep. No big surprise. I would expect nothing else either for the North Atlantic. Oh, look at that. Tuesday, a gale. Lo and behold, 23-foot seas pushing into Scotland and Ireland, that area. So certainly localized wind swell. It hasn't quite given up the ghost, and yet another is forecast pushing into, I guess this would be France and towards Portugal as we get into the weekend. Seas, mainly wind swell. I mean, seas barely made it to 20 feet. And then anything else after that? Oh, and yet another, theoretically, as we get Monday, a week out from now. So North Atlantic refusing to give up, still thinking it is some flavor of winter, even though we are pretty much in the summer mode now. South Atlantic, let's see what the forecast brings there. Small gale with 27-foot seas. Forecast pushing across just about the entire South Atlantic. That should certainly result in swell for Southwest Australia. Nothing huge. You see remnant energy pushing into the coast. Another gale off of South America. And then on Sunday, another gale dissolves off of South America, and that's about it. Finally, to the Indian Ocean on Monday. Little gale fading off of Western Australia, but certainly enough to make for some large, probably raw swell there. Another gale pushing southeast of Africa, traversing the South Pacific. You see some sort of a swell front there and probably another one right behind it. New gale organized, but just doesn't, none of these, they're not like some big lumbering, big cohesive system. It's all this diffuse kind of 25, 26-foot sea type scenario. So kind of a mixed bag. There is surf. Theoretically, a week from now, a concentrated small gale with 30-foot seas off of Western Australia. But looks like surf, but nothing over the top for, say, Indonesia and Western Australia. All right, local wind forecast for California and Hawaii there. Here is our gradient. High pressure, 1038 millibar high. That's pretty strong indeed. Weak low pressure inland. The difference in pressure between the high and the low tightens up the isobars in between them. And then with a little bit of help from the land sort of sticking out into the ocean, creates this Venturi effect. They call it a gradient, a pressure gradient, with north winds at 30, 35, 40 knots off of Cape Mendocino, right at the border between Oregon and Northern California. That is generating wind swell, but you notice you get almost an eddy flow. Low pressure circulates counterclockwise, so you get that south draw up the coast. So you get the wind swell without all the winds south of point Point Arena, I'd say. Put this into motion. Oh, and trades, 15 knots for the Hawaiian Islands. So we get into Tuesday, same sort of deal. Gradient fades a little bit, 35 knot northwest winds. Eddy flow for the California coast, pretty light, 5 knots. Trades 15 knots for the Hawaiian Islands. Wednesday, same deal for California, though the gradient fades, 30 knot northwest winds, 15 knot trades for the Hawaiian Islands. Thursday, gradient sort of rebuilds, 35 knot northwest winds. Still the eddy flow persists. Now, this is actually good. I was talking last week's video with one of our viewers. We were talking about drawing south wind up. Warm water up into Southern California and California. Or Northern California. And the discussion was, do hurricanes actually produce it? Well, hurricanes can, because they have a counterclockwise circulation. They can draw warm water from down south up to the north. But for me, I think it's more this eddy flow sorts of situation because it covers a larger area, and typically they last for a longer duration. Not nearly as strong, but it's that slow, steady push. It's just like the MJO or El Nino or the PDO. It's these long, steady changes in wind direction or wind speed over time that really seem to have the bigger impact rather than short, sporadic, intense sort of events. Yes, they get all the drama in the news, but it's this slow trends that really make the difference. And we would like warm water up into California. North winds like this, that'll create massive amounts of upwelling and cold water. I mean, I expect water temperatures to be down like maybe 49 or 50 degrees at Cape Mendocino. But with this steady south flow up into Central California, maybe we'll get into a little bit of a warming regime. Anyway, on Thursday, trades 15 knots for the Hawaiian Islands. Onward to Friday, same sort of deal. Gradient finally starts fading. Winds down to 25, 30 knots. Trades 15 knots for the Hawaiian Islands. Saturday, the gradient finally dies. Thank goodness. Light wind regime for California. Trades 10, maybe 15 knots for the Hawaiian Islands. Sunday, same deal. Light wind regime everywhere. Now, the bad news is you don't get any wind swell, but if you have southern hemi swell, you don't really want the wind swell anyway. And then we're into a week out Monday. Light northwest flow returns to California. Trades 10 knots for the Hawaiian Islands. Still maybe some minimal wind swell down to Point Conception from this fetch off Oregon, but not a whole lot. No meaningful precipitation is forecast. So now the snow melt is in full regalia up in the Sierra. So we start looking at temperatures for backpackers on the PCT, the Pacific Crest Trail. That's the trail that goes from, I'll say basically Baja up into North Washington along the crest of the Sierra and the Cascade Mountains along the coast, or just off the inland from the coast there. All right, this is temperature forecast for the PCT at Tioga Pass Road there at Tuolumne Meadows, where the two intersect is about at 8,700 feet. You see temperatures 55 degrees at trail level, maybe dropping to 45 to 50 degrees as we get midweek here, and then by next weekend 55 degrees to 60 to almost 65 degrees. So maybe a little bit of a warm up Monday and Tuesday. That'd be the 9th and the 10th of June, but all in all, pretty reasonable temperatures for backpacking in the Sierra. Right, surf forecast for the area, Columbia River, the area in North Oregon, the intersection of Oregon and Washington, near Portland is a bit inland. Surf heights 5 feet on late Monday, probably all wind swell fading to about the 2.5 foot range. Then as we get into next weekend, back up to 4 foot again. All sort of wind swell is the expectation. Northwest winds, 10 to 15 knots earlier in the week, and a little bit stronger at points, but not too bad. Let's look at the actual swell heights. 5 feet at 9 seconds. 3.5 feet at 8 seconds, sort of thing, up to about 4.5 feet at 8 to 9 seconds. A little bit of southern hemi swell in the mix there too. 0.5 foot at 16 seconds. I mean, it's really the northwest wind swell, I think, that will be the major swell producer for the Pacific Northwest. Down into Ocean Beach, San Francisco, surf heights now. This is probably not exactly right. This is a bit off the coast, and it doesn't really take into account the swell shadow. This is a gradient, super north angle, probably like 315 plus degrees. But anyway, you get the general trend here. 8 foot on Monday, down into about the 6 to 7 foot range on Tuesday. Same deal on Wednesday, and then slowly trickling down as we get into next weekend. Notice the winds. There's your eddy flow. South at 18 at one point, south at 16 at another point, until finally the eddy breaks down on like Sunday of next week, and it's just a light onshore flow. Notice no southern hemi swell registering at all. 5 feet at 11 seconds, 5 feet at 10 seconds, down to 3 to 4 feet at 9 to 10 seconds. The southern hemi swell is there, just buried in the wind swell. So we go to Southern California. Same swell is going to hit up in Northern California, but without any of the wind swell. Surf heights 5 feet on Monday. You know it's higher than that at top exposed breaks. Slowly trickling down into 3 to 4 feet to 2 foot range as we get into Friday, and then settling there. Light wind regime. But let's look at swell heights. 3.1 feet at 15.5 seconds on Monday. Slowly trickling down 2.5 at 14 seconds on Wednesday. Another little pulse of energy shows up on Saturday, 1.3 feet at 14 to 15 seconds, and from a more southerly angle. Go to the south shore of Oahu, surf heights 1.5 to 2 feet. Then building up theoretically as we get into Saturday and Sunday. This probably from that new gale that developed south of New Zealand. Surf heights in the 4 foot range. Pretty nice trades. You can see the trades from the east up to 20 knots here, Wednesday into Thursday, settling down a bit as we get into next weekend. Swell heights, really nothing until we get into Friday, and then we're up to 2.5 feet at 16.5 seconds, 2.8 feet at 15 seconds. So good opportunity as we get into next weekend for Southern Hemi swell for exposed south-facing shores. Heading over to South Africa, surf heights 20 foot plus Monday, Tuesday. That's, yeah, maybe somewhere, not at Jeffreys Bay proper. Off the coast, yeah, but it's got to wrap in pretty good to get into Jeffreys Bay. So some fraction, some percentage of this. And then you have west winds at 30 knots. That's a serious wind event. That swell fades off as we get into Saturday, and the surf heights pick up again into the 15 to 16 foot range as we get into next weekend. Let's go look at swell heights. 19 feet at 11 seconds, 15 feet at 14 seconds, trickling down, then back up into the 10 to 12 foot range at 13 seconds for next weekend. So no shortage of swell for South Africa. And then finally, Indonesia, Bali has a good representative. Swell fading out, or surf fading out on Tuesday, only to rebound on Wednesday. 10-foot surf, slowly fading its way down, then bouncing back up for the weekend into about the 8 to 9 foot range. Winds, some version of southeast, 10 to 15 knots the whole way through. Let's look at swell heights. 6 feet at 15 seconds on Monday. Fading off, then back to 7.2 feet at 14 to 15 seconds on Wednesday. That fades out, then rebuilds again up into the 6 foot at 16 second range for next weekend. So just steady, nonstop surf. As one would expect, the Southern Hemi is coming online. It is winter down there after all. All right, let's move on to the long-term discussion, the long-term outlook. We're going to look at the two major weather oscillations that affect swell production during winter and summer months. They are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by talking about the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. The MJO rotates around the planet from west to east on the equator. The active phase on one side of the planet, the inactive phase on the other. They rotate around west to east. The active phase is like a low-pressure system When it moves over your portion of the ocean, it takes warm, moist air at the equator, starts lifting it aloft because it's low pressure. That warm, moist air eventually hits the jet stream, energizing the jet stream, making it stronger, pulling it together, and make it more efficient at digging out troughs and therefore supporting storm development. The inactive phase of the MJO is like a high-pressure system. It creates falling air. That falling air shuts off energy transfer to the jet stream. The jet stream gets weaker and splits, sort of like, I think, what's happening over the South Pacific right now. At least per the models, it seems like some flavor of the inactive phase is in control, theoretically. All right, but let's go see what is actually happening. We're looking at data. Oh, the MJO also affects trade winds, and that's probably the key thing here. The active phase of the MJO, because it's a low-pressure system, well, trades are generated by high pressure. So if generally low pressure is moving over the equator, that will dampen trade winds on the equator. Conversely, when you have the inactive phase of the MJO, because it is a high-pressure system, it will amplify the trade winds and they'll get stronger. So that's what we're looking at here, is a measure of trade wind speeds. This is data from the TAO buoy array, a series of buoys strung across the equator, used for monitoring El Nino, but there are wind sensors on the buoys. This is the East Pacific here, West Pacific here. There's the equator right there. And boom, 180, that's the date line there. That's New Guinea there. So we're just looking at the arrows. These are 5-day average wind speeds. The longer the arrow, the stronger the wind. So trades, just eyeball it, looking pretty strong in the East Pacific, pretty strong in the Central Pacific, pretty strong in the West Pacific. But it is the anomaly, the difference from normal for this time of the year, that really helps sort out, well, are we in the inactive or the active phase? Looking in the far East Pacific, trades look, well, we have one little arrow out of the east here, but everything else seems dead, so kind of normal. Same thing over the Central Pacific. In the West Pacific, trade's a little bit stronger than normal, so maybe the inactive phase or some flavor of it right here. Otherwise, everything else is neither active nor inactive. If anything, maybe this suggests just a very weak MJO pattern, which is not unusual in the summer. MJO is usually strongest in the winter months in the North Pacific. Here is the forecast for trade wind anomalies, 850 millibar zonal wind anomalies. This is the east-west component of the wind up about 4,700 feet, but a good proxy for what's going on closer to the surface. The blues, stronger than normal trades or easterly anomalies. The reds and yellows, westerly anomalies or weaker than normal trade winds. The date line runs right up the middle here. This is the whole planet. The far west Pacific starts right about here. So here in the past, you see we've been in this regime with stronger than normal trades, which is typically associated with La Nina. And La Nina is literally higher than normal pressure over the dateline region. So the neat thing about this La Nina, it was a weak La Nina, so it allowed westerly anomalies to be over the maritime continent, which has actually been favorable because the jet stream runs from west to east right over this area of westerly anomalies. So this winter, it picked up a lot of energy from here as it pushed towards the dateline and across the Pacific. So though high pressure, weak as it might have been, was over the dateline, the jet stream higher up was being fueled by the low pressure bias and westerly anomalies over the maritime continent. As of today, notice westerly anomalies supposed to make a major incursion into the West Pacific over the next 5 days, retracting some and then returning. Whereas back here, it was all easterly anomalies. Now it's starting to do this yin and yang thing, east to west, to east to west, more typical of what would be ENSO neutral. That is a good forecast. Not as good as we'd like, but I'll take it. It's better than where we have been with just steady, nonstop easterly anomalies. Let's keep digging. Outgoing long wave radiation forecast, just fancy words for cloud cover. If you have the active phase of the MJO and it's lifting warm, moist air aloft, that warm, moist air is going to condense as it hits the upper atmosphere, creating more clouds. And that's what this is. The blues are cloudier than normal skies, which would be the active phase of the MJO. The oranges, drier than normal skies, falling air, the inactive phase of the MJO. And let's get ourselves oriented. South America, Central America, Hawaii, New Guinea. EQ is the equator, dateline 180, right down. These 4 charts, 5 days, each panel goes out 2 weeks, 15 days. Weak, very weak. Active phase of the MJO over the maritime continent into the far west Pacific today, 5 days from now, 10 days from now, and fading 15 days from now, per the statistic model. The dynamic model, much more the GEFS. Okay, so this is an ensemble long-range version of the GFS model. A little bit more optimistic, saying weak active, building, and kind of in control of the West Pacific 2 weeks from now. So that's kind of a good thing. Let's go look at the phase diagrams. Same 2 models here, statistic model, dynamic model. How do you read this? Well, the MJO moves from west to east, from the Indian Ocean. That's really kind of where it organizes. Over the maritime continent, that'd be like Bali in that area, to the West Pacific, to the East Pacific, under the United States, we're on the equator again, over the Atlantic, to Africa, then back to the Indian. By the time it gets here, it's very weak. And then it hits the Indian Ocean, gets recharged, and it's back off to the races again. Heavy dot is where the active phase is, so over the maritime continent, so Bali. If it's inside the circle of death here, it's considered very weak. So 1, 2, and 3 forecast tracks have the active phase of the MJO moving to the West Pacific about a week from now, then to the East Pacific, almost into the Atlantic 2 weeks from now. Split between modest strength and extremely weak. The GEFS model has the active phase of the MJO, modest strength over the West Pacific a week from now, and then crashing, but still hanging, recirculating, retrograding back into the West Pacific. So just hanging over there. So this is a better outcome and kind of what the dynamic models have been suggesting for weeks now. Here's the upper level model, another upper level model showing areas favorable for precipitation or short of, it's basically an outgoing long wave radiation chart or moisture in the upper atmosphere, the jet stream level. South America, Central America, New Guinea there. 0 is the equator, dateline run right down here. The greens, areas favorable for precipitation, the red, dry air. So this says active phase of the MJO over the maritime continent moving into the West Pacific on June 7th. These are 5 days each panel. Stronger as it gets into the middle of June, the 12th, the 17th, and then moving to the East Pacific on the 22nd, fading out. Here comes the inactive phase behind that. Another forecast from the CFS model. This is a dynamic model, but it goes out not 2 weeks, but 3 months. Haha, believable? Probably not, but it gives you at least a hint of what's going on. It actually does a pretty good job. This chart also shows the actual MJO in the black contour. So a dotted contour here would be the inactive phase, solid contour, the active phase, but you notice all the black contours have pretty much disappeared after May, suggesting an incredibly weak MJO pattern. Here is the current date. Well, this is yesterday's, June 1st, 180. Oh, you can't see it, but that's 180. That's the date line right there. Okay, far west Pacific starts here. The blues are easterly anomalies, inactive phase. The oranges and reds, westerly anomalies. Notice today, as of today, or as of June 1st, easterly anomalies of any magnitude effectively disappear, and you're left with this very weak easterly pattern, and if anything, maybe a building tendency towards westerly anomalies. Same deal, a week out. Here's westerly anomalies making it to the date line. They back off for about a week and a half, then another incursion of westerly anomalies. So looks like we're setting up more towards a neutral kind of pattern. Okay, let's do one more dive, a deeper, more analysis, more detailed model. Now, this model goes out 3 months. This shows the full length of the CFS model, but past performance is here. The forecast is up here. What's the big noticeable difference? Well, date line right up the middle of the chart here, far west Pacific at 135 east. The difference, easterly anomalies with the blues started getting weaker in April. Weaker, and within a day or two, westerly anomalies are supposed to take over. This is more of a generalized view. That doesn't mean there won't be little pockets of easterly anomalies in here, but the trend is definitely and this model's been saying it for a long time, from a date line dominated by easterly anomalies to a date line dominated by westerly anomalies, and the easterly anomalies move into the East Pacific. So that might mean, I would think, stronger, more like intense gradient northwest winds along the California coast, driven by that, but out to where it really matters, where the jet stream is going to be picking up energy, and I'm looking towards this fall and winter, a much healthier upper level and mid-level situation. So let's overlay the MJO here, Madden-Julian Oscillation. So you see three contours, weak, weak. So here we are current. Weak, active MJO in control, moving to a weak, inactive phase, but westerly anomalies dominating. That is most impressive. And then you get into, starting July 4th, a 3-contour active phase of the MJO in control. Something is going on. Let's overlay the low-pass filter. Here we go. All right, so this shows the real El Nino, La Nina scenario. The dotted contour, the high-pressure bias. We had 3 contours over the date line back in May, down to 2 contours by a week from now. Even that second contour is supposed to be gone. And then we get into the first contour, even that pushing east of the date line by the 4th of July, and then pretty much moving over the East Pacific. No wonder that's what's driving the easterly anomalies there. And here is the 1 contour low pressure bias, the El Nino signal, if you will. Already, well, not really. I'll say by June 26th, it starts really easing into the West Pacific. And by the end of the model run, it's reaching almost to the date line. A full regime change is expected, and I think it's going to be driven by this active phase of the MJO in July. This has been on the charts for months now, so we'll see how it all plays out. But it seems like, give it one more day and we can officially say whatever was left of La Nina is to be gone, and we are going to be in a whole different ballpark even by next week's forecast or next week's video. And now quickly on to the El Nino, La Nina portion of the discussion. We're going to start by looking at subsurface ocean temperatures. These give us an indication of what's going on trade winds. Again, these subtle shifts in the trade winds help drive where the balance of warm and cold water is over the equatorial Pacific. So this is, again, data from the TAO buoy array, the series of buoys strung across the equator, East Pacific here, West Pacific here. These are the anchors on the buoys. The X's are sensors on the anchor lines. They give you absolute temperature values. Use a model to fill in the gaps. You can see where the balance of warm and cold water is in the Pacific. The 29-degree centigrade temperature, that's warm water. See it easing off to the east a little compared to last week at about 179 west. The 28-degree isotherm, I think, was at 160 or maybe even 162 a week ago, now to 158 west. So it's moving off to the east. Why is that? Well, trades which blow from east to west in that direction are getting weaker, allows the warm water subsurface to start moving to the east. That's exactly what we want. Right? But it's not the actual water temperatures, it is the anomalies. The anomalies, difference from normal for this time of year. You see the entire isotherm, typically the 0-degree isotherm is deeper in the west, shallower in the east. You see there is no cold anomalies at all. And if anything, 2-degree above normal centigrade temperatures are building in the east. We have a bit of a bolus of warm water here in the west, and no cold water at all, pretty much signifying the end of La Nina. Let's go look at one more chart. This is a high-res version of that same chart. It also is animated. You can literally see the warm water in the west pushing off to the east. Eventually, this will stop, and I can actually do the details. But you can see the progression that was cold water and now warm water. It looks like a Kelvin wave. Here we go. Pushing off from the west to the east, making it to leading edge of it at 120. This is on the equator, so that'd be due south of California. And a much more pronounced warm water buildup here in the West Pacific. This is all looking much better. This is supported by satellite data. In fact, let's go look at the satellite data. Now, this is not sea surface temperature. This is sea surface height. The satellite goes and measures the difference in sea surface height. If you the sphere of the ocean, if you will, you take out the wave heights, the wind waves, the tides. Is the sphere higher or lower than normal, right? So this is Ecuador here, the Galapagos, New Guinea here. There's the equator. Date lines right here. 0 and yellows say warmer than normal or higher than normal sea height. Same like over here. Why would that be? Well, if you have warm water at depth, warm water expands. It'll displace the surface water above it, giving a little bump on the ocean surface. 0 to 5 centimeters here. The negatives are not cold water, well, they are, but what they're really saying is a depression on the ocean surface. Cold water at depth contracts. When it contracts, it'll create a divot on the ocean surface. And that's what this is. But it is only really 5 degrees north and south of the equator that matters. So we see warm water encroaching from the west, warm water building in the east, neutral water over the equator, and last lingering pockets. Some of this, I think, is that northwest wind just carving out water here, too. The lingering bits, well, some of it's the springtime, typical springtime pattern, both north and south. So, if anything, neutral bordering on warm. And you can see the regime change here over time. This is upper ocean heat anomalies. East Pacific here, that'd be like Ecuador. West Pacific here, as far west as you can get. Here is your La Nina signal. This goes back a year. Cold water in the east. Building, and then just boom, crashed in April. Warm water building in the west and then starting to push off. Is this a Kelvin wave, or is it just the trades have relaxed so the sun can start warming the ocean? I think that's the case here, but I think this is honest, legitimate. I wouldn't call it a Kelvin wave, but because the trades are backing off, warm water is starting to at least push over the date line right there and starting to push to the east. A regime change from La Nina to ENSO neutral. Sea surface temperature anomaly. Again, it's what the temperatures on the ocean surface are really what matters. What we were looking at before was subsurface temperatures. That's what primes, eventually they rise up to the surface, but that's sort of like the primer. It's the foundation. But it is the actual water temperatures on the ocean surface. Warmer ocean temperatures support evaporation. Evaporation supports uprising air, which then imparts energy to the jet stream and does a whole host of things. Whereas colder water doesn't support evaporation. You get that high pressure downward falling air pattern over. Just this morning's update, June 1st, right over in here, it looks like steadily the expanse of neutral to slightly warmer temperatures is getting a larger footprint over the bulk of the equatorial Pacific. Just 5 degrees north and south of the equator. That's what matters. You have warmer than normal temperatures already here over off of Ecuador and the Galapagos. You have plenty warmer than normal temperatures here north of New Guinea. But the official El Nino monitoring region is from 120 west, 5 degrees north and south of the equator, out to 170 west, right in here. And just eyeballing it, it almost looks like we're darn near neutral here. In the Nino 1.2 region, here it seems like for sure we're positive. But out here, this is the one that really matters. And if anything, we're maybe 1/10 of a degree below neutral. That said, all those temperatures have been corrected to supposedly account for a warming planet. This is a totally alternate strategy where they just say, what is the average temperature over every square mile of the ocean around the world? Use that as your starting point and then say, well, are temperatures warmer or colder than that, everywhere across the planet? So what they're saying is, well, temperatures are cooler than the average here in the equatorial Pacific, warmer in the east, warmer in the west, but not as, and you can't see it, the equator is right there. So you can almost sort of make it out. But this says, well, the oceans are still slightly biased cold. Now, this doesn't have nearly as much history as the previous chart does. This is sort of an experimental chart, but it gives you a good idea of maybe an alternate viewpoint. Here is the sea surface temperature trend for the past 7 days. Definitely warming here, and these cooling right up along Ecuador just a little bit, but warming over most of the Nino 3.4 region and Nino 2 region for sure. So this looks like trades for sure are backing off and a warming regime is setting up. Here is the uncorrected, or more or less uncorrected, Nino 1.2 index temperature trend. This is the area right there by Ecuador and the Galapagos. Today's value were 301 thousandths of a degree above normal. There's neutral right there. Okay. And in the Nino 3.4 area, the official El Nino monitor region were 246 thousandths of a degree below normal. So let's be clear here. Anywhere from half a degree above to half degree below is considered neutral. ENSO neutral, it'd be ENSO neutral. Okay, so we're below zero, but we're not in La Nina anymore. And it appears that the trend is heading up. All the data suggests that's the case. So I think we're in a pretty good place, slowly warming as we get into summer. The official corrected sea surface temperature anomaly for the Nino 3.4 region, just updated here, the 28th of May, this morning, 1/10 of a degree below normal. So, and you can see the trend. We've been effectively toggling normal since February, 3/10 of a degree below, 3/10 above. I mean, it bounces around a bit, but basically right at zero. What does the atmosphere think is going on? So we have the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, roughly on the equator. Darwin, roughly on the equator, over the maritime continent. When pressure is lower in Tahiti, the index goes negative. Oh, minus 6.75 today. Okay, yesterday -1, but where have we been? Well, you see, we were kind of in a positive regime there the end of May. But then prior to that, well, it's all just been kind of bouncing around. That was the only real positive trend I've seen the past month. We can use the 30-day average to sort of tease out, sort of get out of the weeds and see what's going on. Positive, 3.63. So not, positive is more La Nina-ish, but you really would need to be up at 15. And if you wanted to be in El Nino, you want to be down at 15. Where have we been the past month? Well, we were at 0, we went down to -3, now we're up to plus 3.63. So this looks like the normal weak MJO effect, as the MJO active phase pushes over Tahiti, the index goes negative and then it rises. Okay, 90-day average is your El Nino, La Nina indicator, plus 4.96. Where have we been? Plus 5.39, just scanning the data. We're really going nowhere. Let's look at this on a graph. Here's the 30-day moving SOI graphed out. You can see here's neutral, +7 to -7 per the Bureau of Meteorology in Melbourne, Australia. Here was our La Nina up to +15 at times. The upward spikes are the inactive phase of the MJO. The downward spikes are the active. So you can see the push to neutral here in May and June really pronounced. Here's where we are today, about as neutral as you can get. So again, the data just suggesting ENSO neutral. What is the forecast for sea surface temperatures in the official El Nino monitoring region from the CFS version 2 model? Well, here we go. About as neutral as you could possibly want. In fact, let's go see April. These are all actuals here. May, as dead neutral as you can get. In June, in July, temperature going up to maybe 0.15 of a degree, holding back to neutral in November and January. You get the idea. Interesting, though, about 3 days ago, this was actually showing that we would be dipping more into the negative, still like minus 0.2, nothing that, ENSO neutral. But now the model has sensed something and is saying, well, maybe neutral biased, weakly warm. Now, let's be clear. We just are getting out of the spring unpredictability barrier. The models have a difficult time knowing exactly what's going on. And if anything, it seems like spring is maybe lasting a little bit longer. I mean, the normal, that's typical during La Nina years. So we are out of the spring unpredictability barrier officially, but I don't think we really are yet. It just still feels very much like spring. Just looking at the gales still pushing off of the U.S. East Coast up into Ireland. Again, this tendency for strong northwest winds down the California coast all reek of a late spring pattern. And if that's still the case, the models, I think, would be a little bit unstable as to knowing specifically what's going to happen with La Nina and El Nino. That said, looking out further, it looks like a westerly wind pattern is trying to develop over the dateline. But let's zoom in real quick here. First off, we have swell in the water in California. That is southern hemi swell. And another one forecast, that same second swell is also bound into Hawaii about next weekend. And the second southern hemi swell into California for the early part of next week. And then after that, things sort of settle down. Looks like maybe the inactive phase of the MJ or something, the Jetstream. I mean, maybe it's not MJO related at all, and the Jetstream is just going to weird out for a little bit. I mean, that's not unusual. Typically, it's in July when I see the Jetstream get really weird and funky. So we'll see what happens. A week out from now, it could be a whole different ball game. But looking longer term, again, it looks like starting today or tomorrow, westerly anomalies build over the dateline, and that pretty much signals the demise of La Nina. That said, when it happens, it's 3 months from there until for the upper level jet stream flow to sort of respond to it. Okay, I think the jet stream is still biased towards La Nina, again, with the low pressure systems in the northern hemisphere still sort of dominating things a bit weird in the southern hemi. So we'll see. But long term, the model's suggesting ENSO neutral, and I think that's probably as good a guess as any. You tell me what you think. Do you think actually we're going to be biased towards El Nino, or maybe fall into another La Nina, or will we actually, for the first time in decades, have a winter that is fully ENSO neutral? And what would the impacts be? My guess is that the jet stream will be decently set up, especially if those westerly anomalies build over the dateline. That should make for a fairly strong jet stream. That should make for a good, consistent surf pattern as we move into the fall and winter months. And it should portend of normal rainfall into California. But again, when you're in the neutral pattern, it can kind of go either way. It could signify just a total lack of momentum in the atmosphere, and then who knows what's going to happen. But anyway, let me know what you think. But that seems to be my prediction for right now. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. I think we just hit the 7,000 subscriber mark. Every subscription helps. And if nothing else, makes me feel good that people are watching and they're interested. If you have a comment or question, write it up down below. And if you'd like to make a small contribution to the cause, you may. I always appreciate your contributions. It means a lot to me. And I know everyone works hard for their money. So anyone that has a little bit and they send it my way, I do really appreciate it. All right, that's our video for this week. This is actually the makeup video. I'll leave them both up there. You decide which one you want to watch. And we will do this again next week. Same time, same channel. Thanks so much for watching.